Hi everybody, I'm Radwa Diep, your science teacher. Let's learning something very interesting today. Are you ready? Let's go. Okay, our today's topic is about the factors that affect the reaction rate. Okay, so today, here is our lesson objective for today. Okay, so today we have to define, which means we have to know about the rate of reaction, what the rate of reaction means, and we have to investigate how the temperature, surface area, the catalyst, and the concentration it change the reaction rate. Okay, ready? Okay. Guys, here, as you can see, we have two pictures. One of them is, yes, the fireworks, and the other one, yes, iron rusting. Guys, do you know the meaning of rusting? Yes, the rusting is the brown layer that forms on the iron, okay, on the surface of the iron. So, my question here, what makes some reactions faster than other reactions? Like the fireworks, it happens in a second, but rusting of iron, it takes long time to happen. What makes reactions faster than other reactions? That's what we are going to investigate today. Ready? Okay, so here we have an experiment, okay? We're gonna start our topic by doing an experiment. I'm gonna do it in front of you. But before we start, I want to ask you how the temperature can change the reaction. What do you think? Okay, so here we have effervescent tablets. Okay, do you know these tablets? I got vitamin C tablets, the effervescent tablets. Okay, I'm gonna use two tablets here, and we have two plastic cups. You can use, of course, two glass cups. It's hard to get the, yes, here we are. Okay, so I have two plastic cups here, okay, and I have the effervescent tablet. I'm gonna place each tablet at each cup, okay, as you can see here, and we're gonna use a stopwatch. Okay, why we're gonna use a stopwatch? I want you to measure the time taken for each tablet here to dissolve in the water. But we're gonna change the temperature of the water. We're gonna use hot water and we're gonna use cold water, okay? And we're gonna measure the temperature taken, we're gonna measure the time taken by each tablet to dissolve completely in water, okay? But I have a question for you, of course, here. What do you think? Which one will dissolve faster? If we use a hot water or if we use a cold water? Okay, excellent. Do you know why? Okay, let's figure it out. So, guys, here we have the data table. We need to, okay, we need to, okay, here I'm gonna share my screen. Okay, so we're gonna use the data table in order to fill in the blanks. What I mean here is that, okay, we have to measure the time taken by each tablet to dissolve completely in water, and we have to record our findings here, okay? So let's start with the hot water. Here I have hot water. Let's see what will happen. Guys, ready? Okay, here. Guys, can you see what is happening here? Can you see? Yes, there's fizzing here and bubbles produced once we pour the water, the hot water over the tablet here. Okay, I have to start the timing. Okay, it's completely dissolved now. There's no pieces are left here. So let's stop. It took like 16 seconds. So we have to record here 16.5 or point, sorry, point 26.26 seconds. Okay, almost 20 seconds, 16 seconds. Okay, now we have the other cup with the same tablet, other tablet, I mean, of the same kind. Let's try the the cold water in this time. But before I pour the water, I have to reset the stopwatch here. Uh, Here we are. Guys, can you see what is happening here? Yes, you can see the fizzing and the bubbles produced, but at lower rate than the other one, right? So let's leave it aside until the whole tablet dissolve in water. I think it, yes, now it's 19 seconds and still there is the tablet here. Okay, it's not completely dissolved as you can see here. Okay, so let's wait until it's completely dissolved. Okay, guys, it's done now and it took like 2 minutes to completely dissolving. Okay, for completely dissolving, it took 2 seconds in cold water, which means that at the hot water or by increasing the temperature, the speed of the chemical reaction increases. But by using the cold water, it decreases. So here, what do you think, guys, here? How quickly reactants turn into products? What the meaning of reactants? Yes, the reactants, they are the substance that enter a chemical reaction that react together. They are called reactants. And the result is called, yes, the product. So how quickly they react and turn into product? This is the meaning of the reaction rate or the rate of reaction. Rate of reaction means the speed of reaction. We measure the speed of each one of each reaction by measuring the time taken by each one to dissolve. So the rate of reaction means how quickly the reactants turn into products. And how we can affect this rate, we have four factors affecting the reaction rate or the speed of the reaction: the temperature, surface area, concentration, and the catalyst. Today, we have investigated how the temperature affects the rate of the chemical reaction, right? Okay, so here we're gonna find out why the temperature affected the rate of the chemical reaction. Let me show you the, okay, let me show you the simulation. Number 2, let's start our experiment, okay? As you can see here, the particles of the reactant, how they move. Okay, guys, who can describe the movement of the reactants here? Yes, they are moving slowly. How we can make them move faster? Excellent, by raising the temperature. Let's increase their temperature and figure out, or we can observe what is going on here. What happens to their movement? Yes, as you can see here, the number of collision increases. They started to hit each other more frequently. And this is how the reaction happens. Okay, excellent, guys. So here we can explain why the temperature, or why by increasing the temperature we increase the rate of the chemical reaction, because by increasing the temperature the kinetic energy increases, so the movement of particles increases and they start to collide even more frequently with each other. The answer to the question, I want to remind you that we have four factors affecting the speed or the rate of the chemical reaction. Who can tell me what are the four factors? The temperature, surface area, concentration, and the catalyst. Okay, from these four factors, what do you think that you can do so you can slow down the food browning? Excellent. Okay, now it's the game time. Okay, hopefully. Okay, here we go. So guys, I'm gonna divide you into two teams, one for boys and one for girls. Okay, let's start by with the girls because ladies first. Okay, pick a number, please. Okay, for example, 10. Okay, the term used to describe the speed of a reaction beginning with R is excellent, rate. Okay, the boys team, can you pick a number? Okay, excellent. Thank you. So let's wrap up our topic today. Who can define the meaning of the rate of reaction? Okay, so the rate of reaction means factors affecting the rate of reaction. We have four factors: temperature, surface area, concentration, and catalyst. And how the temperature affect the rate of the chemical reaction? Who can answer it? Yes, by increasing the temperature, the particles gain more kinetic energy, so they start to move faster, and we have here more collision between the particles. Excellent, guys. Okay, by the end of the session, we have a final assignment. Okay, we have to do it during our lesson today.